All right. Welcome, everyone. This is Data Analytics 2. This is exploratory data analysis. And this, of course, is class 1. And we just posted a link in the chat on Zoom for anyone that wants to make sure they have access to the resources for this course. Last time we bundled all the resources for the entire course on one page on OpenHub, but given that there's so many resources we're going to be sharing with you in this course, we're splitting them out page by page, so each class has its own page. That's just to prevent any confusion, because it gets confusing after a while. You see so much stuff, and we don't want you to get lost in the stuff. We want you to have fun with the data and analysis, right? So I'm so glad to see all of you here. I think you're going to enjoy this class. The format is very much the same as the prior course. If you remember in our very first data analytics course, not the one we just did, but the intro, we shared our Google Colab notebooks, right? So hopefully you all remember those skills on how to do that. You will need to do that after you do your homework, right? You need to post the link, but make sure that anyone with the link can see your goodies, right? Can see your notebook. If you just share the link, sometimes and you don't specify the name of the person, they're not going to be able to access it. And of course, you're going to be able to share it on Slack so we can see all of the goodies. I'll explain homework towards the end as I normally do. All right. So I think what we'll do is we'll get into the lecture first. We're then going to do a warm-up exercise in Python, which I think you'll enjoy. I'll walk you through that. I'll walk you through downloading and extracting the file if you haven't done it already, which is fine. And then once we get our feet wet, we feel comfortable, we'll start the Airbnb exercise. That exercise may take several classes, which is fine. More than likely, it'll take 2 classes, but I want you to feel comfortable. I know some of you did some Python work in between the classes, which is wonderful. So what we're doing is we're testing your Python skills and making you feel comfortable, but adding some code that you might not have seen before to create some really cool effects. All right. Okay, let me go ahead and share my PowerPoint with you. This is not going to take too long because it's a shorter PowerPoint, but as usual, it has a lot of good stuff in it, which is well, that's the goal, right? That's the goal. Okay, so this course is all about exploratory data analysis, and really what that's about is getting at insights from your data. So this is descriptive statistics or analytics, I should say, plus more. All right, so we did some descriptive statistics, things like mean and mode and things like that, standard deviation, and that's part of exploratory data analysis. Sorry about that. But we're going to take it to the next level. So we'll review the descriptive part and then we'll extend past that. So EDA is one of the first steps in the data analysis process because the goal is to start the exploration into the data, looking at the data, examining it, to look at its main characteristics. Typically, when you download a data set, you may not know the specifics of what it contains. You might have a general idea. Maybe someone said, here's a link to a data set that offers some data about some patient data about COVID and some of their medical data, right? So maybe they had blood work done and what have you. So you have a general idea, but it's not until you look at the data set and you start that visualization of it and you look at it, you say, I see that the columns have this type of data. So once you do that, you then are going to decide how you're going to approach exploration, but also visualization using graphs and other types of techniques that will help you visualize the data so that you can gain a better understanding. So the goals of EDA are simply to understand the data, to detect patterns and relationships, to generate hypotheses, to guide data pre-processing, and also to communicate insights. So it's very important that each of those steps are gone through and yet you don't rush the process. So in a nutshell, it's a preliminary step before you go to any more complex data analysis. You always do EDA to get a gist of your data and what's there. It helps you as the analyst become familiar with your data, but also uncover patterns that may be interesting or problematic. You might start seeing outliers, right? You might be seeing data points that are not usual or not normal. And so that gives you a chance to think about, well, how am I going to address those outliers, right? So it informs your subsequent analytical tasks. Your next steps in the process of analyzing your data are created based on what you learn from EDA. So it's an iterative process. You do it over and over again. It involves visualizing, summarizing, exploring, and again, to gain insights and make informed decisions about next steps. You may, during the process, just so that you know, during EDA, you might decide, I don't have enough data to work with here. Or the data has major issues and I need to decide, can I clean the data and make it work for me? Is it missing a lot of values? What types of things do I need to think about? So of course, there are many, many, many Python libraries for loading data and working with data. So this small list is about loading your data. You can use Pandas, NumPy, SQL Alchemy, PyODBC, Requests, and Beautiful Soup. That's just some examples. We're going to be working primarily with Pandas and NumPy as a starting point. But as you take these courses, over the boot camp, we'll be working with a lot of different libraries over time. So it's always important to be familiar with what libraries are out there. And if you're coding in Pandas or Python rather, look for Python related libraries that are, the latest rage or old standbys like Pandas and NumPy. So there are folks out there that are writing libraries to help data analysts do their job. So as you get familiar, you'll learn about new ones and say, wow, this one's really cool. Maybe this makes my workflow more efficient. All right. So the choice of library that you choose depends very much on the source of the data that you're working with and the requirements. So, you don't have to use fancy libraries. You can keep it simple. The goal is to keep it simple and not get fancy until you need to. So the data overview is basically, we've done this before, basic statistics, the mean, the median, and so on, right? You determine what the data types are and the extent of any missing values. It's possible that you decide that I need to convert my data types because let's say I plan on using categorical data and the data comes in, it's categorical. We learned what that is, but it comes in as an object. And Python or Google Colab, I should say, says, oh, this looks like an object, but you want to treat it like a true category. So I'm going to walk you through different types of pre-processing we can do or data cleaning. The other thing you commonly do is display the head, which is the first 5 records of the data set, and the tail, which is the last 5, just to see, do we have kind of consistency or something along those lines. If you see the tail is completely blank, you know something happened, right? And as we learned in Excel, if our table range goes past itself, we have a lot of blank records and we don't want that, right? So we want to make sure that the data looks as we intend. Also, you want to determine the shape of the data set. So just knowing how many columns and rows. Now, when you import the data, when you ingest it into the system, if it takes a long time, you can make an inference that, hey, maybe this is a big data set. It's always good to know ahead of time what you're working with. I worked several years ago with a group of data scientists on a COVID data set from Mexico. And the Mexican government was providing this data for free to all the data scientists so that they could get some help with addressing COVID in their region because they didn't have enough people to make a semblance of what was going on. These data sets were updated daily and they were millions and millions of records. And so it was a great way for us as data scientists to provide our skills to another country that lacked the skills of data scientists, but at the same time work with these monster data sets, which is always fun because you never know what you're going to get into, right? Um, All right, so visualizing data in EDA is important. We all learn different ways. When we visualize something in a graph, sometimes things jump out at us differently than if we look at it in a table. So visualization is always going to be part of EDA. It facilitates your ability to explore, look and find patterns, recognize those patterns, and also gain some insights. So your ability to understand the data, communicate what you see in the data to someone else who maybe is not technical or data science oriented, and then make decisions and convey those things to someone else is really going to be useful. So visualization is really about communication, and you don't want to communicate the wrong things, and sometimes a chart will help you. So some examples of Python libraries used for data visualization are things like matplotlib, seaborn, plotly, altair, and bokeh. We're going to be working with the first three tonight: matplotlib, seaborn, and plotly. And I'm going to explain why. They're each different. They all have the ability to do stuff, generate charts, but some of them are more enhanced in some of the libraries than others. Some have some really cool features. So for example, matplotlib is the run of the mill, right? You always start with matplotlib. But then if you want some maybe fancier colors, fancier interactive, you go with seaborn. And then if you really want to kick it up a notch, you go with plotly. So I'm going to show you some of the differences between them. So one of the reasons we talked about data distributions quite a bit prior, we create histograms to show numeric data, either continuous or interval data, and how it's distributed. So remember we talked about the bell curve, and we talked about it. Well, that's a histogram, and you're always going to have the x-axis and the y-axis with a histogram, and that allows you to see the frequency or density of data points within each interval. The bars in a histogram also show how the data points fall within each interval. I'm going to show you an example in a minute. So it allows you to see the shape of it, determine whether it's skewed. Remember, we talked about skewing both right and left, and also look for central tendencies and detect any outliers or things that fall outside the tail. So bar plots are used for showing how categorical data are distributed. So here's some examples. So just out of curiosity, we've got two charts on the screen. Which one is the categorical one? Which one do you think? Is it the blue chart or the yellow chart?
I think the blue.
The blue, correct. Points. Yes. So remember, they label their categories as A, B, C, so on and so forth. Think of it as nominal, my name, right? So that is definitely a bar chart, and that is categorical data. On the left is a histogram, and you'll notice that the histogram has kind of a bell to it. There's not a lot in the tails, right? But it has kind of like a mountain, a peak at the top, and then it kind of levels off, kind of like a bell. This is a mostly normal distribution. I don't see any odd, issues here, but we do see that one of the towers in front of the middle tower is a little short than the other one, right? So we see here in the middle, we've got a real tall tower, and to the right, we've got one that's, slightly shorter, but on the left side, that one is not as tall. So it's not quite a bell, but it'll do, right? Notice that we're describing the number of lamps. Notice the y-axis, it says number of lamps, and on the x-axis, we're describing lifetime in hours. Okay, so this is the number of hours that the lamp lasts. So these are numeric values, but they're also continuous. So we would not use a histogram for categorical data. It's not designed for that. It's designed for numeric data. So that's just something to think about. And just the nuances of difference. So the one on the left, the yellow one, is a histogram. The one on the right is a bar chart, and that is for categorical data. All right, so exploring relationships and patterns. Now, typically you're going to use what's called a scatter plot. I'll show you an example in a minute, but a scatter plot is used for bivariate analysis involving two numeric variables. So when you hear bivariate, A variate is like a variable. They sound very much the same, but bi means two, right? So bivariate analysis allows you to see two numeric variables. You compare X to Y in essence. You take each data point, you plot it on the X axis and see how it plots onto the Y portion of the plot, as it were. Correlation analysis is looking at the degree and direction of a relationship between two continuous variables. So again, the degree is the strength of the relationship and the direction is the direction, negative or positive, right? So if something has a positive relationship, as one increases, the other increases. If it has a negative relationship, as one increases, the other decreases. So theoretically, if we eat less calories, right, we decrease calories, our weight should go down, right? Or something like that. So that would be, as one goes up, the other goes up. If I eat too many calories, my weight goes up. If I decrease my calories, my weight goes down. So that would be a positive because they increase and decrease at the same time, right? Um, but if one thing increases and the other decreases, so for example, the more calories I burn through exercise, the less I weigh, right? The weight goes down. So increase exercise and the calories I burn, and then the weight goes down. That's a negative relationship, right? Can you imagine if the more we exercise, the more weight we gained? Unless you're a muscle built, muscle lifter, whatever, muscle man, muscle woman, the goal is to not add weight, but to decrease, right? So that's just something to think about. And then we have the pair plot. Now, we will be doing pair plots in this class down the road, but pair plots are awesome because it allows you to combine many different pairs of numeric variables and see them in this huge plot. So let me show you what that looks like. So on the left is a scatter plot. So you'll notice that here we have the x-axis and on the, and that's the horizon, right? The vertical here is, our y-axis. And what we've done is plotted our points to see. Now, what you see on the screen is, I'll give you a quiz, a mini quiz. Is this a negative or a positive relationship?
Negative.
Negative, thank you, right. So anytime it starts at the upper left and goes down to the lower right, that's a negative relationship. A positive starts at the lower left at the 0, right, and goes towards the top right. That's a positive. So it's very easy to see that direction. It gives you an idea as to the data points, where they fall, how much scatter, right? Now, this is somewhat clustered around, the data points are clustered around. They're not really tight in the center, but they're somewhat. If they were all over the place, then they would be super scattered. So looking at the chart on the, or the, I should say the pair plot on the right, you can see that all of these scatter plots here are very scattered and all over the place, right? The histograms are pretty normal. We have a really nice bell curve for this one and this one. This one's a little leaning, right? So this is right skewed because it has a tail on the right. And same with this as well. So you can kind of see that a pair plot is great because it shows you, combinations of two variables at a time. And it lets you digest a lot at one point. All right, so let's look at how we would analyze categorical variables. Now, a frequency table, which is on the right-hand side, is a classic way of looking at categorical variables. We will be generating some of those tonight and working with them. So if I wanted to see what frequency of fruit I have in my, my refrigerator, I have 7 apples, let's say, 5 bananas, 9 oranges, and 3 grapes. Only 3 grapes. What can I say? Someone's been hungry. I know that I have 24, pieces of fruit, as it were, and I know with what frequency each of these fruit items are found in my refrigerator. So you might look at it and say, well, we're low on grapes, therefore I've got to go buy more. Or someone was into my grapes, I need to talk to them about that. So it tells you a lot of information, even though it's in this compressed little table, right? The frequency table is something that's very commonly used, but also what is used is a bar chart or a stacked bar chart. So if you have multiple categorical variables, in this case, we're looking at colors of clothing, equipment, and accessories, which people tend to match the color of their clothing to maybe the equipment that they're, using, like maybe glasses or what have you. And accessories might be things like belts or bracelets or what have you, right? So here we can see the relationship, for multiple categorical variables. This just so happens to involve revenue. So you see revenue on the y-axis, and you see the different locations of a purported store, Cherry Street, Strawberry Mall, and so on. So they're looking at, how much revenue they're pulling in for things like clothing, equipment, and accessories. And you can see that it's a very symmetric relationship, right? So clothing is number one, right? Revenue wise. Equipment is second to clothing. Peach Street tends to have, it looks as though that Peach Street has just as much as Cherry Street when it comes to equipment. So that seems to be a popular sales category for those two locations. And then of course, accessories is very similar across the board. And each store has, specific revenue related to that. Now, which item is the most popular out of all three?
Clothing.
Is it clothing or is it accessories? What do you
Oh,
what do you
for
think?
the top, but it doesn't, it's on the top.
So the bar color is proportional. So you
Oh,
are correct. So the clothing is the largest. It has the most color for blue, right?
right,
And then the gold is the equipment, and then small is accessories. And that makes logical sense, right?
right.
So when
Ah,
you're interpreting this, the colors, it's almost like a pie chart. When you see the slice of color, you get to make inferences about which one's the largest. You do the same thing with this type of chart. So visually, it helps it jump out at you, right? It helps you visualize it, and you can see the nuances of differences between like the gold, right? And you can see that Peach Street and Cherry Street are very similar in volume, right? Because of the size of the gold. Does that make sense to everyone? So visually very helpful. All right. So another thing that we do in EDA is called data pre-processing. So what data pre-processing is used for is to handle missing data, detect outliers, and decide, of course, what you're going to do about those outliers and engage in some type of cleanup of said outliers. Data normalization and standardization, which we've mentioned prior, and also encoding categorical variables. We did one hot encoding. We talked about that at the end of our prior course. We are going to do some one hot encoding in these courses as well. So you'll get some experience in that. There's different ways of encoding: label encoding, one hot encoding, binary encoding, target encoding, and frequency encoding. We're going to be looking at all of these using hands-on work. But when we think about encoding categorical variables, it's as simple as taking what's in the cell, right? The value that's in the cell, and changing it to a different value, which is it stands for the category, but in a different way. So in the example of one hot encoding, if someone bought the red shirt, right, we made it a 1 because it was hot for 1. If their order had a red t-shirt, right? If it was orange, we made it a 1. If they didn't get a green shirt, we made it a 0 for that order. So we know it's either ordered that color or not. It's really binary. All right. So in summary, the purpose of EDA is to extract meaningful information from data to inform your future data analysis tasks. Very important. You don't want to just jump into it. Every step of the process is careful consideration based on what you're presented with. Sure, there's going to be typical practice that you bring to bear, but you always want to look at the data set in front of you and make very specific decisions based on what's in front of you. So you want to, be able to ask the right questions to identify issues that are potentially going to happen either now or in the future, and also be able to detect the valuable insights that are in the data. Remember, it tells a story. So ultimately, if you engage in a very methodical step-by-step approach, you will arrive at a more effective solution, but rushing the process can jeopardize your result. So you want to be very careful that you take your time in doing this. All right, any questions about anything we went over in here? And on OpenHub is a PDF of that same lecture. So definitely download that and take a look at that. All right, so what we are going to be doing, by the way, if anyone just joined us on Zoom, make sure you put your name in the chat so that we have your attendance. Also, you want to click on the link that was provided by Yulia to make sure you have access to the course and the resources. We are going to be working with, the first data set we're going to be working with is our family budget data set. So what you want to do is get that downloaded. It's a zip file. You want to extract it and you want to put it somewhere where you can find it. So that's going to be the first step of this exercise. All right. Okay, so I know some folks just joined online, so I want to make sure everyone gets a chance. In the meantime, I am going to get on my screen. Basically, where the next step, I'm actually going to walk into Colab and I will share that with you. If anyone gets stuck with extracting, remember you can reach out for help. Just either raise your hand in the classroom, or if you're on Zoom, put something in the chat and we will help you. All right. I'm going to go ahead and share my screen. Okay. All right. Now, if you've already downloaded your data file and you have extracted it and you have that CSV file, either on the desktop or in downloads, you just want to know where it is. If you feel comfortable, you want to then log into, or actually you would be in Google Drive, hopefully, but if you're not, log into Google Drive, and you want to create a new Colab notebook. And you can name it Family Budget Warm Up like I did up here. And we'll wait till everyone gets to this point before we go further.
So who doesn't have the account with Colab yet? Round one, are you doing Colab? Yes, Colab, yes.
Yeah, so if they've set up a Google account, they should have access to Colab, but we can walk them through. So, yeah.
Yes, a couple students who do not have Colab yet. They do.
That's fine. Okay, no worries. We will wait for them.
Yeah. Also, I believe Hiral, she's on Zoom. You don't have Becky on Colab yet? Yes, she's coming.
Okay, okay.
Couple minutes.
All right, no worries.
Maybe just guide us again.
Absolutely. Okay, so I am going to close out. Let me jump over. So if you have a Google account, so I have a Google account. Does everyone have a Google account or no?
Yes.
Okay, so if you have a Google account, you want to go into Drive. And the easiest way to do that is to go from Mail. And I'm going to just, let me move my thingy out of the way here. You go from Mail and you click on what we call a hamburger on the upper right-hand corner. Does everyone see my screen, hopefully? My Gmail showing? All right, and you're going to click on Drive, and that's going to take you into Drive. Can everyone see that there?
Yes.
And then what you're going to do is click on New, and you're going to go all the way down to More, and you should see Google Colaboratory. Now, if you don't see Google Colaboratory, if that's not in your list like mine is here, you're going to scroll all the way down and click on Connect More Apps. Okay. And you would search for Google Collaboratory. As soon as I type COL, see how it pops up? I'm going to select it, and then I'm going to add it in. Notice it's okay, and I have it installed, so the only option I have is to uninstall, but you want to install it. Now, what that does is it installs it into your Google Workspace in your Google Drive. So it's just another type of application or document that you can work with, just like a docs or a sheet, right? Or slides. It's just another flavor, if you will, of document that you can work with. So once you've done that, then you can just create a new, go down to more and Google Colab. You create a new notebook.
Go to Drive. And it's asking what's new.
Just trying to choose the name to family budget one. So let's see. Family underscore budget underscore warm-up.
There you go.
Right now it's untitled. When they open it, it's untitled, they have to name it, right?
That's correct. And the way you name it is you just come up to this little title bar and it'll say untitled, which is not a very good name, right? Because it means nothing. You can just highlight the untitled portion and make it what you want it to be. I'm naming it family underscore budget underscore warm up. And that just helped with readability of the file name. What's going to be useful, little hint, hint, wink, wink, you're going to use this warm up as a way of focusing on your homework. So you're going to use this as a guide of what types of code can I use for my homework file to analyze the penguins data. And I'll go over that at the end of tonight. But so warm up is your key. That's the file you want to use.
But you can always rename it if you have time, but it's okay. Oh. That's fine, that's fine. Just click it here and you want to put the cursor and then, yep. How's our Zoom? People
Good, hopefully. Anyone struggling on Zoom?
What?
Zoom.
Oh, I'm like. Thank you. Okay, you're good.
Everyone's okay? We're ready to rock and roll?
Looks like that.
All right. Okay, so the next thing we're going to do is now we haven't done this before. Let me see, we've got someone on. Okay, so everyone's good on Zoom. Again, on Zoom, if anyone gets stuck, don't hesitate to put a hand up. There's a little at the bottom of your Zoom. You will see a way of sharing sort of expression, and that will pop up. So under reactions, for those of us on Zoom, you can raise your hand, and that should pop up and jog me. Or if you post a question and someone in the Zoom knows the answer, they can help them. So that's always appreciated if you can help a fellow student out in what you're doing. So Hiral, are you good? It looks like you say no. So are you okay? Okay, so okay, what's the name of the file you need to download? So off of Open Hub, I think you mean? Okay, okay, so on Open Hub, you want to make sure you use the link that is, and I'll post it again here. So Hiral, this is the link you're going to use. Make sure you click on that and that you have access. If you do, let me know. And then what you want to do is on the lower right, you'll see outline. You want to click on that and click on class 1. And then you will see the file. And the file we're working with is familybudget.zip. It's a data set. So let me know if that works for you. And we keep our fingers crossed. And we'll just give Hiralic a moment to get access there. And Yulia, I assume Haral has access, yeah?
It does.
I figured that. Okay. All right, good, good, good. So can someone watch the chat for Hiral just to make sure? And I will move forward. Or would you like me to wait? I can definitely wait. It's either or. We don't want to leave anyone behind for sure. Especially when we're talking about family budgets, right? Focusing on your budget and your finances is very important, right? And how cool that you can analyze data related to your budget. It tells you how much you're spending on different things.
This is not Hiral, this is Shalon. I
Okay.
find the family budget file.
Okay. So I will go ahead and share a different screen. Hold on 1 minute. Move this out of the way and let me share Open Hub. I have to just open it back up. Okay, let me go ahead and share this. So, okay. So do you see this screen when you log in?
No.
Okay, you probably are looking at this screen.
Oh, yes.
Okay, so you want to scroll down towards the bottom right and you're going to see the word outline. And underneath there's a link. It's like a button for class 1. You want to click on that. That'll take you to the resources for this first class. We broke it up so that we don't clutter up so much all the classes together. Makes it easier. So this is the file that you want. Family budget data set warm-up exercise.
Oh, yeah, I don't have that. The link to the class 1.
Okay, so it looks like Shalon has to be added, Yulia, to the individual class.
She is.
She is, okay.
Okay, I see it now.
Oh, you do. Okay, good, good. So you see the same thing that's on my screen?
Yes.
Okay, so yeah, this is the file you want right here. Family budget data set, warm-up exercise. It's a
Okay.
zip file.
All right, I have it downloaded now.
All
Thank you.
right, and you want to extract it so that the zip file extracts its contents, and you want to put the CSV file somewhere where you can find it.
Okay, thank you.
You're welcome. You're welcome. All right, so I'm going to jump back to our warm-up. Okay, so everyone has this. Now, one of the things that we focused on in our last Google Colab exercise, our fun time, was getting into different code to accomplish different things. But we didn't really talk about how to organize our project from a top-down point of view. That's what I typically cover in this class. So right now on my screen, I have a code cell, but I really don't want this code cell. So if you have a cell on your screen like I do, you want to come over to the right-hand side and click the little garbage pail to delete it. I want it totally blank. And the reason I want it totally blank is I want to add something different. I can create sections to organize my code. All right, so I'm going to come over here to the table of contents button. It's on the left-hand side. It looks like 3 dots. I'm going to click on that. And it opens up a table of contents. When you organize your file using a table of contents, you create clickable sections that you can quickly click and get to another section. So the first section we want, we're going to click on section, right? Like I just did. It's going to come up as a new section in the middle of the screen here. Everyone see that? We're going to double click on new section, and that's going to take us into the code behind. It's basically the markup. This is called markup. So I have a hashtag in new section, and what the hashtag does is it changes the formatting. All right. What I'm going to do is I'm going to replace the words new section by highlighting it. I'm going to type project background. All right, and then click underneath the cell to update it. And the other thing you could do is basically click out of it into the section area to update it. Now, if it does not update, sometimes this happens. You notice mine is not updating. What you can do is you can create a new section. So I'm going to go ahead and do that because we're laying out the outline. So I'm going to come back over here and click on section again. And now I'm going to create a new section called import libraries. So what we're doing is we're laying out the outline of our project, import libraries. Okay. Everyone good so far? Import libraries. All right. I'm then going to add another section. Again, we're just adding sections right now. And in this one, I'm going to double click, get into the code behind the markup, and I'm going to type import data. Again, we're adding different sections for our notebook so that we can organize our thought process as we go through. I'm going to click on the section button again and add a new section. And I'm going to call this one data exploration. Now, the data exploration part tends to be the biggest because it's what we do in the beginning when we're scanning our data to look at it for different patterns. The section that follows after that is our data pre-processing. So I'm going to add another section called data pre-processing. Okay. I'm then going to add another section. You see there's a pattern here, right? Another section, and I'm going to call it data analysis. What story does the data tell? And again, you don't normally have to put what story does the data tell, but we're learning, so why not, put that in there to kind of guide us. I'm then going to add another section for data visualization. And you can see here, we're creating an outline for all of our work that we're going to be doing. And then the last section is going to be our conclusion. All right, that's our last section. All right, now when you have that last section, if it looks like this, right, if you click to the right on the actual preview, that will update it. So you can see we have quite a few sections here. We'll wait till everyone gets those sections in. Project background, import libraries, import data, data exploration, data pre-processing, data analysis, data visualization, and of course well, I put in the wrong thing here. This should be conclusion. So I just realized I made a mistake. All right, insights gained. Okay. Does anyone need me to scroll up or down? You can kind of see the table of contents on the left-hand side. Just want to make sure you have each one of those. Now notice I can click on each one of these and get to that section really easy. How cool is that? So this table of contents is clickable. So it is the proper way to organize your notebook, whether you're doing it in Google Colab or later on, I'll be showing you how to do it in a Jupyter notebook outside of Colab. This is just a very important way to organize yourself. Anybody stuck? Everyone okay? Everyone getting there? Anybody need help? Can I go forward? I don't want to rush. All good? All good. Okay, it sounds like everybody's good. All right, now, what's super important is when you mouse over, like project background, right? You'll notice if I move my mouse to the center of that bar, I get the option of inserting a code cell or a text cell. We want to insert a text cell. This text cell is going underneath project background. So it is not part of the table of contents. Okay. Now, whenever you create a new project, you want to make sure that you describe what it is you're doing. I'm going to go ahead and just paste this in here so that you can type it, because basically I'm going to update the screen so you can see it. Our project background involves a hypothetical scenario. A financial advisor has been asked to, and you are that advisor, by the way, to provide some insight to a family on their finances. Using bank record data representing last year's activities, descriptive analytics is used for exploratory analysis to determine what spending occurred by category. So you're describing what the project is about. What are the goals, right? Or this is actually the background. We're going to do the goals in a second. Okay. Now, the next thing you would do, because every project should have a set of goals and every project should have specific questions that you have at the start of the project. You may, as you start looking at the data, you may decide to change your focal point and add some additional questions because maybe you saw something in the data that jogs your inquiry. You become curious and so on. This is exploratory data analysis. So I'm going to add the goals and the questions to the same cell. The way to get back into a cell is simply double click on it, and I'm going to paste this for ease of your viewing because I type slow, and I will update it so you can see it. Okay. And let me make sure that this is not indented. It appears to want to be indented. Let's do this like so, and we'll leave it go. It's a glitch. All right. So the project goals is to understand what columns are available and what data values are present. The second is to detect overall spending trends and patterns in the data. The third is to determine whether unusual spending occurred in any given category or month. And the questions that we have are, how much of the budget is allocated to each category? Is there any category that stands out as either high or low? And does spending change throughout the year? Now you'll notice that my questions continued the numeration from the goals, and we don't want that. So I'm going to come in here and fix that. This is an example of a little glitch, and it's because it's too close to what's above it. You see, so I had to put a white space in between the two lists so that Google Colab treats it as a separate entity. And that's how you fix that. All right. So if that ever happens to you, just put a white space in between your prior list and the next, and that'll keep it segregated and distinct.
I'm sorry, I have a quick question. I was typing. Do you just continue typing? Like, for instance, I had the project goals and all that, made that white space and then start typing that, or did you add a new text?
I did not add a new text. So all of this is in that same cell.
Oh, okay.
But it is separate from project background, right? So yeah.
Right, okay.
You got it. You got it. Now you'll notice if I double click and go in here, we've got 2 pound signs in front of project goals. So 2 pound signs and a space. And notice that project goals is sort of, it's a heading. It's a level 2 heading. Whereas if we look at project background, it's a level 1. So depending on the number of hashtags, that determines the level of heading. And that's why I have them there. I want them indented, right, as a second level of heading. Also, notice that our toolbar up here has the ability to create a numbered list or an ordered list or, here we have the ordered list and this is the bulleted list. So you can either type in these things, or you can you can click on one to add a bulleted list or a numbered list. Both of these are numbered lists. Okay. And we'll wait till everyone gets done. If anyone gets stuck on Zoom, you know what to do. Remember, you can put the hand up, or you can type something and I should be able to see it.
Can you repeat the steps you said to fix the indentation problem?
Yes, absolutely. So I'm going to double click in here and notice if I take that white space out, right, it gets confused. And if you look at the preview here, it gets indented here, and it also continues the numbering from the prior list. And that's because I don't have a white space. So what I'm going to do is click at the end of the word month after the period and just press enter, and the preview updates accordingly. So it's just that it doesn't see it as a distinct list. It actually sees it as part of the prior list.
Thank you.
You're welcome. All right, everyone okay? Everyone good?
Don't move it so much. I'm still typing.
Quick question.
Mhm.
These questions, are they from the family or from advisor, created by advisor?
It's
Or by-
created by the advisor. That's actually a great question. So typically, if a family or a client comes to like a financial advisor, they usually don't even know what to do with the data, right? So they may have general questions based on, how a family perceives their finances, but they may not be able to know what's possible when it comes to analysis. So they're usually just going to come to the advisor and say, here's my data, tell me what I need to do. you know, Tell me, and they may say, well, are we overspending in certain areas? They might phrase it in those ways. But you can assume that these questions are what the financial advisor has established as their goals for the analysis. They're going to start there. Now, down the road, as they go through the data, additional questions may come to light, and they may add those in. And the reason that they do this is it guides their analysis process. But then when they do the debriefing with their client, in this case the family that came to them, they can say, when I started this analysis, I created a set of questions to guide my analysis, and these are the questions. And so the client would have a common understanding as to what was the goal, what was the basis of inquiry, right? Because what you will then do, and what's super important, is your analysis will actually address each of these questions. You won't miss anything, right? Your goals of the project is overall, right? They're high level goals. So you want to make sure when you go back to your client, you can say, well, I now understand what columns are available and what values are present. I was able to detect overall spending trends and patterns in the data, and I was able to determine whether unusual spending occurred in a given category a month. The other thing to think about is when you have a client give you their data and say, help me, they may not even know where to start. So you may, before you start with your exploratory data analysis, come up with a list of goals and go back to the client and say, here's what I see as the project goals. Are you okay with this? Or do you see something else that you want to add? And they may say, yeah, let's add this, this, and this. So by having those questions handy, that might jog their mind into, wow, I need to be thinking about this, this, and this. So it's a great way of structuring your approach. The other thing that's important too is if you're contracting with a client, you will then be able to build these goals into your contract. So now there's a common understanding as to what the goals are. There's a common understanding of what questions will be answered. That is the insight that you're giving back to your client or your employer. And so everyone's on the same page. And that's the other key aspect of this. So this is in essence documenting your project, the scope of the work for this project. So it serves a multitude of purposes. It's a great checklist for you as the analyst as well, to be able to go back and say, yes, I covered everything.
I have a quick question.
Mhm.
So are we under the assumption that this advisor is an expert in finances and that's why he's able to come up with these questions? Because for instance, if I'm the
Well,
advisor.
he's a financial advisor, so if I'm paying him, I would hope he's an expert in finance.
Oh, because the questions sound so fancy, like if a client comes to me, I'm not gonna be able to come up with those questions unless I'm an expert in that field, correct?
Well, the questions are, so when you say the questions are fancy, like they're oriented towards finance, right?
Right, yeah. But-
So these are questions that the financial advisor who is an expert in that domain
Okay.
came
Will-
up with, right? Right, exactly. So now when you're speaking with like the family members, right? If you say how much of the budget is allocated to each category, they have different categories for their expenses. So like entertainment, food, and when you explain it to them, they will understand, oh, okay, I understand what a category is, right? So families often will divide their budget into, um, you know, um, um, what I spend for groceries, what do I spend on insurance, whether it's car insurance, health insurance. They kind of have a general idea, so it wouldn't be too confusing for them. And if by posing a question like, is there any category that stands out as high or low in spending, your average person that is keeping a checkbook could understand that, right?
Mhm.
So they know if they're spending a lot on, let's say, Netflix and streaming, right? Or they know if they're spending a lot for spa days, or even groceries, right? So I know my grocery bill's going up because prices are higher. So most families would understand that. And then also, does spending change throughout the year? Most families would know, well, yeah, our budget for movie going or, going to sports camps during the summer grows because we're out, with the family, school's out, right? So spending changes during the summer because of the activities we're doing, right? Or maybe holiday times or something. So most people, and that's a good point. You want to make sure that the questions are something that everyone can grasp. And these are set up in that way. And most families understand what unusual spending is because it's just a topic of the dinner discussion. How much did you spend on spa day? How much did you spend on auto parts? How much did you spend on video games? Or something, right? So
Right,
most,
yeah, music or whatever.
right. So most families know, you
Yeah.
know, um, you know, and that's why, it's important to help, budgets are very important for so many reasons. Whether it's a family trying to manage their finances or it's an organization trying to manage their finances. It could be a project specific budget, anything. So it's really important to be able to analyze it. All right. So can I go to the next step? Is everyone good? Yeah?
Yep.
All right. So we're assuming that everyone has downloaded the zip file and they have extracted the file, the CSV file from the zip file, and they know where it is. All right. Has anyone not done that before I go to the next step? Yes. All right. So to import your data, we have to manually import it. And I'm going to show you how to do that. So if you come over here, remember we clicked on table of contents. We're going to go all the way down to the icon that looks like a file folder. All right, you see that there? Looks like
Yeah.
a file folder. And you have an icon with an arrow pointing up. Now, it's not the black one, that black file folder. It's this one above it. Does everyone see that? Everyone see that hopefully? Now this will allow us to upload our file to the session that we're in and store it temporarily. Okay, so I'm going to click on that and I'm going to click on familybudget.csv. And it's basically saying, make sure your files are saved elsewhere. The runtime will be deleted when the runtime is terminated. We're going to just ignore that and say, okay. Okay. So you should then see familybudget.csv in this file structure here, just like I have on my screen.
Oh, I didn't see it, okay.
And we'll go up.
All right. And again, we clicked on this one. It's the white folder, looks like, with an arrow pointing up. And we browse to where that familybudget.csv file is. And that uploads it into this session. Now, one thing that's super important, if your session, and mind you, we're on a cloud system, right? If you get disconnected for whatever reason, you may not be able to access your data. You may have to do it over again because it'll delete that file. Okay. It doesn't matter. Your code can still execute it, but it needs to get to that file. So you would just need to upload it again. This is one way of doing it. We're going to cover many different methods for uploading data into Colab. This is the first. We're starting small. We're starting simple. Okay. Was everyone able to upload the data file?
Click on that one and then open. Okay. Thank you.
It sounds like we have some pros in the house here. You guys are getting better and better at this. It's a good thing, right? It's a good thing. All right, I'm going to move forward. Everyone's good? All right, so now what we need to do is we need to actually import some libraries. So here's what we're going to do. Notice import libraries. When you click once on that word import for import libraries, and you move your mouse over to the center, we have the ability to add a code cell. We're going to do that so that it goes under import libraries. Okay. Everyone able to insert a code cell with no problem, right?
For library?
So,
Yeah, it usually shows over here. So then, code. Code. Oh, okay. Oh, okay.
It's a code cell. So remember, you have two flavors. You've got a text cell and a code cell, right? So we want a code cell because we need to execute code to be able to import our libraries. Now, I copied and pasted it in so you can visually see it. We are going to be importing quite a few libraries. And the reason we're doing that is because we want to do data analysis and manipulation, math. We want to work with the date. We want to work with matplotlib, which we talked about earlier for creating graphs. We also want our plotly because that is going to be used to enhance our graphs and make them gorgeous, right? So all of these imports are important. It's also important that you can put the comments in so that you know which does what. Okay. So you'll see I comment the code to help you. So we'll get it typed, and once you have it typed, then we're going to execute it. Okay. And I'm just going to go ahead and execute mine so that you can see I purposely created an error. Boy. So you will notice, and I did this on purpose so that you guys understand, this little guy right here, the one with the, looks like the percent sign, is not an import statement. It's an inline statement, okay? It's a function. It will not allow a comment to the right of it because it just won't do that. All right, so I'm going to move that comment underneath. Okay, so that's just a little trick of the trade. When you see something that doesn't have purple in the beginning, you can't put the comment at the end of that line. You've got to put it either above or below, like I have here. Okay, so that's just something to remember.
Just typing something. Oh, oh. This is right here.
And I'll just scroll up so you can see
Oh.
better. Now, it's good rule of thumb to put all your imports in one location at the beginning of the file, okay, like we have here. You will see out in the world cases where the imports are done piecemeal throughout the project. In other words, they're done at the point you need that library in the project. There's two schools of thought on that. I prefer to have everything organized in one area. This way, if something's not working, I can go back and say, is this library even known to my project? Do I have access to it? If you have to scroll through a large project, it could be really difficult to find it. So that's why I'm showing you this method.
Oh, yeah, sometimes, sometimes you just have to. I'm not really used to. Okay, so just in this second, just in case, because if you have to pass it pencil, that's usually.
Did any of that matter? The cap.
Yeah, caps don't matter, and so is indentation, which you will see from last night, just because the language is like very fussy most of the time.
Now, where you see dots or periods, make sure that you put them in, and because that's dot notation. It's called dot notation, and that's an important way of referring to the library and then functions under that library. So much to learn, right? So much to learn.
Now, the number of spaces that we leave in between words do matter, correct?
Yes, yes, it's a single space. That's a very good point. So, right, it's a single space between words.
Okay. Sounds good. Yeah, so spaces.
Hey, Professor,
Yes.
after we finish typing, do you want us to run it or just wait?
You can run it. You can run that cell after you're finished typing it to make sure it works. That's a great
Okay.
point. Absolutely.
I gotta get rid of that face. It just appeared out of nowhere.
I thought it looked wrong.
Which one did that have a lot of yeah, okay, that one's.
This kind of itself, like, really, like the mark plot left in line. You know, this always happens to us.
Oh, no, space.
Wait,
Yeah, yeah, so, yeah, that.
but you
That's-
say one space. You do,
No, that's fine. I'm saying like after this period here, that's like, that you should add a space because if you said one of the libraries,
Oh,
functions for them, so you will have to.
oh, okay, so that's why you added that extra. What about implemented?
It's not, yeah, for whatever reason they make you correct things, that's not.
No.
I'll show you. Sometimes.
Oh, okay, there we go.
Okay, so yeah, sometimes you can just click out of it, like click on any other.
Oh,
line.
okay, because, oh, that's why. I didn't-
Because if you press censor, it's just going to
I-
make it that function, you don't really want to, like, inline from that, that's how.
Okay, I see what you mean. Listen, children, I didn't get to, I didn't tell.
Okay, so now let's see, so with that check mark.
Oh, okay.
Because we ran, because I ran the code. Right. Like, that's what that means.
Awesome.
So while we're waiting, one of the things to remember is the words or the abbreviations after the word as are your variable names that you're assigning, so that as you're, for example, referring to pandas throughout the code, you can only, you're going to refer to it using PD instead of typing out pandas. Same thing with NumPy. As NP means I assigned a variable called NP. So PD and NP are commonly used as variable names for pandas and NumPy respectively. Same thing with matplotlib, PLT, Plotly Express, PX. And of course, graph objects are Go. So you want to keep it simple so that you use that same convention each time you do your projects, and that you follow the common way of doing it. Because if you share your code with someone else, they're going to follow the standard that everyone else uses. So did everyone get this cell to execute? Is
Yes.
anyone still trying to get it? Everyone's good to go? I can move forward?
Yes.
All right. We're going to insert a code cell under import data. Okay. Because we are going to import our data using this code right here. And I'm going to explain what this is doing. Once you get it typed, I will explain what it's doing. Keep in mind that DF is a very common variable name for my data frame. The data frame is what holds the data in memory in the session of Google Colab as I'm working. So if I need to get to the data, I'm going to refer to the data frame because that's where the data is. What I'm doing here is I'm using the pandas library. Notice PD dot read underscore CSV is a command, a function to read a CSV file with the argument provided in parentheses, the name of the file. All right. So it assigns the reading of the CSV and assigns that data to the data frame variable. And that's how you import your data into the notebook that you're working in. How cool is that?
So you're saying that every time the front part of it, we just type that up? And
Say that
then
again.
the DF equal PD dot red dot underscore CSV. We always type that and then whatever file we are importing in there.
Well, no, it depends on the type of file. If you're not reading a CSV file, you're not going to use the read underscore CSV function. You would use a different function. So Pandas has a lot of different functions for reading data. Okay, so to demonstrate that, and you folks don't have to do what I'm about to do, but I'm going to just show you something here. So if I did df1 is equal to pd dot, and I go to type read, right, I can actually bring up all the possibilities, okay, of the different files. I could read an Excel file, right? So you see how it gives me the choices here.
Cool.
Okay, so in this case, we're working with a CSV, so we're reading a CSV. But if I was working with Excel, like an XLS file, I would use Excel. And if I was reading a pickle, which I have done, I would be reading a pickle. So again, it's kind of cool. And the reason that that's important that you pick the right one is each of these file types have different characteristics and capabilities. So that's why you have to tell it what you're doing. I'm going to go ahead and delete that cell because we don't need it. All right, everyone's good there. Now you ran the cell and you got a green check mark, yes? Which means, okay. So if you did not run it yet, then you wouldn't have a green check mark. If you ran it and you got an error, you want to see where the problem is. Again, the ability to run this command means that it assumes that your data has been imported or your file has been uploaded, I should say, into the current session, like I did here. If you haven't done that, you're not going to be able to execute this command successfully.
So mine is telling me the file not found.
Okay, so do you see your file on the left-hand side, like on my screen? Do you see the file like on my screen here on the right? I'm sorry, on the left-hand side?
Oh, see, yes.
You see the files, right? You see
I'm
the
kind
files.
of confused.
So what?
Wait, my file?
So if you uploaded your file into this session, you should see it here. Now, if you don't see this little outline like I have there, you want to click on the little folder looking icon and that expands it, and then you'll see your outline. If you don't see the family budget.csv file, that means you didn't upload it from the system. So you want to click on this icon right here. Looks like a white sort of page with an arrow, and upload the file. And it's the familybudget.csv file that we're uploading. And once you upload it, it should appear right here.
Down here.
That's just like, oh, that's just a common
It's there. It's just, it comes and goes.
It counts to the green. That's fine.
Okay.
It's just a simple.
How did you get the files? How did you get to the left menu? Sonia is asking.
Okay, so if the left menu is not showing, you're clicking on this folder icon under the X over here on the left.
Yeah, that's right. Then you click there. You see the number that's.
Oh, no, it's just.
And once you have this showing here, you're clicking on the icon that looks like a page with an arrow pointing up, not the black page, but the white page. So it's upload to session storage. It's right under the word files.
That was there, so that one.
Thank you. It's something good now.
Yep. Now, once you've done that, then you should be able to run this command with no problems.
And then you close the files to get rid of the left menu, right?
You can click on that, yes, and get rid of it.
So you expand or.
Right, you can either expand it or you can collapse it. If it's in your way, it's a good thing to, collapse it because you don't want to see so much on the screen, right?
Yeah.
Okay. Perfect.
Okay. All right, everyone good?
Yeah.
I'm still having a problem though. I don't know if I'm doing something wrong because
Okay.
the file is already uploaded, but it's still telling me my file is not found.
Okay, so when that happens, if you can see on the screen familybudget.csv, if you can see it, the file on the left, then you visually know it's there. Make sure that the file name matches what you have referred to in the parentheses and that you have double quotes around it.
And the spelling of CSV is that.
Now, the other thing to remember is this depends on you having imported your libraries. If you have not done that, then Pandas does not, it's not recognized by your notebook, right? So you have to make sure that you imported libraries before you run it. So I would check your file name, make sure it's identical, case matters, right? And make sure you have double quotes around the file name in the reads underscore CSV.
But yes, but like the other things.
Yeah, the images. I don't know why it's moving.
Maybe soon we can share her screen.
Yes, that would be
Go
perfect.
right ahead. Go right ahead.
Yeah, thank you so
You're
much.
welcome. You're welcome.
Oh, just give me 1 second.
No problem. Let me know if you don't have access to sharing. You should be just fine.
No, I have access to
Right, but because I manage this, sometimes that's turned off, and usually I leave it turned off.
There's so much opening now. Oh,
Okay,
that.
so can
Wait,
you
not this one. I'm sorry. I think I'm sharing something different.
well, I
No,
see I see a collab notebook, so
yeah.
can
um,
you
can you
can you maximize your screen by clicking on the box up by the X? Nope, not that one. That will minimize to the right. Keep going
Okay.
to the right.
Oh, this one?
To the right. It looks like a box.
Okay, I'm gonna bring it out again. Ah, Lord, this is so much
Well,
going.
if you next to where your cursor is right now, right there, there you go.
Okay, huh.
Yep,
Can you,
yep.
so this is what okay.
Okay, can you click on the folder? Okay, so you're in the wrong spot over there. You want to click on the folder. So you have yours on the left, on the right hand side, excuse me.
Yeah.
All right, so can you scroll up in your code, please? Okay, so let me just make sure. As PD, okay, da. All right. So somehow, some way, you've uploaded into a different location, it appears.
Oh,
Yeah. So did you like scroll through your file structure or something along those lines?
so I went, this is what I did. I don't know why it's showing on the left hand side. So I even go back to go
Okay.
upload it again.
Well, can you go ahead and do that? Let's see where it goes. Because it looks like you got, this is going into the default structure for Google Colab. So basically, it looks like you clicked up a level. So what we need for you to do on the right-hand side,
Okay.
what you want to do is you want to click on content. So scroll up till you see content. Nope. Nope. On the right
No,
hand side, scroll up, keep going, and then click on content. Nope.
content.
The
Oh,
word
yeah,
content.
okay.
Content. Okay, now click on the white page with the arrow pointing up. No, up
Why?
the white page, the one that you used to upload. Nope, the
All
one
right.
right there. Okay, click.
Okay.
Okay, and now click family budget. It
Okay.
assumes it's in the content folder. If it's not, it can't find it. There you go. So now it should appear under sample data, and I don't see it. Click to refresh. Oy vey. So content is open, but it's not there. So can you expand sample data? Just click there. It didn't go there. Okay. Let's see if we can drag it from
Okay.
where it is up there.
Okay, so I'll go back
No,
to.
you're not dragging content. You're dragging the file name. Remember it went down below?
Oh, yes.
Okay,
So
so
this one.
right. So right click on it. Does it give you the option to move it? Let's
Just tell me to copy part, delete file.
I can see your screen.
Okay.
Just
Oh,
go
I'm
ahead and click
sorry.
go ahead and click delete file. Yep. Yep, we want to get rid of it there. Okay, now we're going to scroll back up. All right. And we're going to click on content and but expand it again. So just double click. Yeah, there you go. So now we're going to go to the arrow that you did before and grab family budget and hope it behaves itself. All right. Fun times, right? And of course, it's not going to behave, right?
Mm-mm.
Of course, of course.
I
All
don't
right.
know what he's doing there.
Well, it's okay. It's all right. You don't really need to know. It's, you know, so what
Yeah,
I'm gonna,
he's going all the way
I
down.
see it. I see it. So are you able to drag it? Just click and hold and drag it up to keep going, keep going, keep going. Don't let go.
Mhm.
Uh, keep going. Will it let you drag it? Probably not.
Oh, yes, he's
Oh,
letting.
Okay, okay. Now
okay.
lay it on top of content. That's okay. If you put it in there, we can drag it one more. Right on content and let go.
Okay, I like
Yeah.
Okay,
Yeah. Now that was a long drag and drop. That's hard to do. So you did an excellent job. So
thank you.
now that's okay. So now try running it again because your code is correct. Looking at it. So go ahead and try running it again. Yay.
Yay,
Cool
it
beans. All
works.
right.
Thank you so much.
You're welcome. So, rule of thumb, folks, when you're doing this for homework, right, make sure it's in the content folder. And if you
Okay.
accidentally clicked on the wrong arrow, you'll get into the whole file structure, which looks like a big mess, right? It's
Right.
all the system stuff we don't want to see, right? So, yeah, just be careful. If you get stuck, remember if you watch the recording, what happened here. So, I'm glad you make that mistake. That's good because someone will make that mistake. I know I've done it. We've all done it, and then
Mhm.
you're like, wait a minute, where am I? Right? So no worries. Okay.
Okay,
All
okay.
right. All righty. We're going to go back to our exercise. Let me go ahead and share my screen. Um, Now, this might seem like easy stuff, but I have to tell you, if you can't access your file, you can't really do much, right? You need to have the access to the file. Now, we have our file basically available to us because it's in this session. Next thing we're going to do is put a code cell under data exploration. Now, the purpose of this first code cell, we want to know how many rows and columns are in the data frame. So we're going to put a comment. Remember, all comments start with a hashtag. How many rows uh, and columns? Now, again, um, I'm putting this comment in for you. If you're new to this, you want to put comments in so you know what your code does, right? So once I type my comment, I press enter. And in order to determine this, I need to refer to the shape of my data frame. That is done by pressing df dot shape. All right. That is the code. That's it in a nutshell. What is the shape of my data set? df dot shape. So when we do that, we know we have 361 rows and 5 columns
Oh,
in our data set.
okay.
So that tells you how big the data set is. Now, this happens to be a rather small data set, but that's okay. We did that on purpose because we're just practicing, right? Now, another way of determining, I'm going to put a new code cell down. I might want to know how many elements or elements are in my data frame. So I'm going to type how many elements. Now you might be wondering, what is an element? I'm going to explain in a minute. Are in my data frame. How many elements? All right. And the way you do that is you type df.size. Now, if I were to take 361 times 5, I would get 1805. That is how many cells. If you think of Excel and we have a big table or range of data, and it helps if I fix my typo here. Right? We know in our range we have so many cells. Well, that's what this is telling me. How many cells do I have in my matrix or my data frame? And that's 1805. So again, if you multiply the rows times and the columns, you should get the same number. If you get something different, be very afraid. Go grab more coffee and pray, because they should be mathematically the same. All right. The next thing we want to do, we're going to add another code cell. And we want to know which columns are present in the data set. Now, again, this is the beginning of discovering our database or our data frame, which is in essence like a little database. So how many rows are in the data frame? this is another way of determining how many rows. Now, we did this earlier. We got the shape, but let's say I just wanted to know the rows and not the columns, which is very common. All right. I would do something really cool called len, or length. Len df. What is the length of my data frame? And that's how many rows. How cool is that? So there's many ways to accomplish very similar tasks is the point I'm trying to make. So how many rows and columns, how many elements are in my data frame, and how many rows are in the data frame, right? Now, another thing we can do, and we're going to bring down another code cell, is we can show which columns are in the data set or the data frame. Show the column names in the data frame. Okay, now the way that's done is df.columns. And make sure you put a dot, not a comma. It's a typo there. And when I execute that, it gives me in the index, which is at the top, sort of the header row, the names of the columns. So transaction ID, description, category, month, and amount. It also gives me the data type, which is object, because the data frame is an object. The columns in the data frame are objects. So what this is telling me is not what the data is perceived as, but what the object that I've asked for, which is the column. Okay. Notice this is exploratory in its form. So everyone good so far?
Yep.
All right, we're going to bring down another code cell. There's a pattern here. We're doing this all the time, right? And now we want to determine what our data types are. So we want to identify the data types. And the way you do that is df.dtypes. Dtypes. All right. So I have 4 columns that are objects and one that's a float 64. One is perceived as numeric, that's the float, and the others are objects. Now, they're objects, and therefore we can infer that they're highly likely categorical. Now, I will share with you that sometimes Python and Google Colab or whatever, IDE you're using will perceive it as an object because it doesn't know what to do with it. It looks at the data and says, I don't know, I think it's an object, we're going to call it an object. So you yourself will know once you look at the data whether or not it should be treated as categorical or not. Okay. Everyone good thus far? You guys are becoming pros. This is getting scary. All right.
Question.
Okay. And you have a question?
Yes, a quick question. Is there a way to practice or learn more like the different categories and like to be able to kind of grasp that, or does that come with experience?
Well, throughout the boot camp, we're going to be working with different data types. So I would say your best way is to take a boot camp and learn about the different data types. And as you use them, you will start seeing how you can analyze them. So for example, there's going to be times where you want to use a particular variable in a certain way, and you may be able to convert it, or you may not be able to convert it. Or if you convert it, there's limitations. So as we go through the boot camp, we will be working with many different data types. So I think over time, as you work with them, you will get used to what they are and how they act. Yeah. So I mean, you could also do research online for, data types in Python and what they all are. I would definitely encourage that. For now, I'm not overloading you with a lot of additional resources in the course because I don't want to overwhelm you. So there's a lot of links out there, but this is definitely something you could Google. If you're curious now, if you're curious now and you have the stomach for it, right? Right. Okay, so we're going to bring down another code cell. Now what we want to do is we want to identify summary statistics. Sounds really mysterious, right? Summary statistics. Now this sounds very much like descriptive statistics in a way, but it's not. Summary statistics is very valuable in that it allows you to see the index, the name of the column, how many non-null cells there are, meaning has data. So non-null, it's a double negative, God help us. It has data, how many of them, and the count of the non-nulls and the data type. So it gives you a nice table. So let me show you what that looks like. df.info, parentheses, parentheses, open, close parentheses, gives you a great sort of just a tabular view of some very valuable information, or what we call summary statistics about our data. Now, what's super important for me, the first thing I look at when I see this is, are the non-nulls even? Notice every column has 361 records that are non-null. The size of my data set is 361 records. I have no problems with nulls here. I'm a happy girl. I'm a happy girl. This is very unusual. I created this data set for you because I love you and I don't want to give you trouble with your data right off the bat, right? I'll torture you probably in next classes, but not now. I made it nice and clean, right? So we don't have any nulls. Now, does that mean we don't have any garbage data? It may mean that we've got goodies in there, but we know there's stuff there, right? We don't know what it is, but we know that it's, we have 361 non-null. All right. And again, non-null is not blank, not null. All right. Now, to verify that what we're seeing is true, and it's not playing tricks on our eyes, because when you see this, you get really excited. We're going to bring down another code cell, and we're going to do a double check. So we're going to check again for missing values. Now, the reason I'm doing this is it's always good to be sure. So there's another way that you can get a count, how many for each column. Now, right now it appears we have none. So what we're about to do should show us that in fact there are zero. It would get an actual zero, non-null, or zero, I should say, is nulls, right? Talk about logic, right? So it's df dot is null. All right, and then we're basically going to do parentheses, parentheses, dot sum, parentheses, parentheses. So sum up all of the nulls for each column. That's what that means. So run the isNull function on the data frame and sum up all the isNulls. That's really what that means. Notice how important dot notation is, those periods, right? So we see that there are zero for each column. So we're not losing our mind. We know there's no nulls. And again, we're very happy. But let's say you're still not sure and you want to try another way. There is another way, and I'm going to show you. So we're going to bring down another code cell, and we're going to check for NA values. Now, NA values are different than nulls. How are they different? Who knows?
I noticed you did a space after as such. Was that an accident?
That was an accident, and it actually, it doesn't matter. So you're correct. I did.
Okay.
Yep. No. And usually I try to be consistent, but my fingernail got caught in the keyboard. Um, so does anyone know the difference between a null value and an NA value? Remember Excel class?
Well, would an NA literally have NA versus just a blank?
Okay. Everyone agree?
Yes.
Okay. So NAs are special, right? They are really interesting, but they're also, they're important for us as data scientists because we need to know if they exist, because they're nonsensical. They have no value. And if they're NA, we need to find out why and what we're going to do about them, right? Because we have nothing to learn from it other than it's NA. And that's not very exciting, right? So the command we're going to type is df is NA, right? Is it NA? Again, it's a function, so parentheses, parentheses, dot values, right? Dot values. And instead of value counts, we're going to type values dot, values dot any. Are there any NAs? So we don't want to know the number of NAs. We want to know, is there any? Okay, and that's what dot any means. And if it comes up false, that means, guess what? None in the house. We have no NAs. It's like winning the data science lottery. We have no nulls and no NAs. We are golden. We are golden. Now, something that's important to
It's
remember.
something that we should be doing every time we actually get a data. And we're going to
Yes, that's
use it
why
as-
we're doing it. Yep.
Ah, good, okay.
Yeah, this is, remember, this is not like this is actually how you would really do it. So just so you know, we're not just writing code and, there's actually a workflow here that I'm teaching you. Whereas in the first course, we did it kind of combining code and such. But yes, you're actually checking this way.
Oh,
Maya has a question.
This would include any variation of NA?
Yes. So now here's what's interesting. NA typically is written just NA. This is only going to take the NA as without any special characters. So like a hashtag NA is not going to be perceived. So yeah. So again, it's very important that you understand that. Yes, that's a very good question.
Oh.
All right. Because a hashtag NA might mean something different. Okay.
Of what that data was, that what was assigned in that data that you're actually trying to verify, correct?
Correct. So
That
if you mouse over that is an A function, notice what it's telling you. It's looking for missing values. Okay. So now, if the values are NA, notice how it has the capital NA. The other thing it will map to true on is a none, because a none is also perceived as uh, basically nada, right? None. And so it recognizes that as, okay, if it sees it, then it is true. Otherwise, it ignores and says false. So if it's NA, either it should accept lowercase and uppercase, all right? Then it perceives it as what's called an NaN or NaN, right? And so it maps it to true because it's NA, or it'll flag it as false. And so if you ever want to know what a function does and the possibilities, you can actually look here, right? You can also Google under pandas and find out more about what exactly this is telling you, right? Because you don't want to make any assumptions about what a function does. Now, notice when I mouse over the any function, it does all kinds of stuff. It's a method, and it basically is saying any means in the matrix, in the data frame, right? And this is how it does its search. And I'm not going to get into all of the code here because it's more complex, right? But it's looking for any instance, as it were. Okay. Now, if there were missing values, we would have to make a decision about how we're going to deal with it. Also, if there's NA values or nuns, we would also have to deal, because that has implications for our data analysis. So let's say, we'll just play devil's advocate. Let's say in the amount column, we found a lot of no data where there was no data, or a lot of NAs. Well, this is all about our budget, right? And this is all about determining how we're spending. If we've got a lot of nuns or NAs, well, maybe we're not spending in those categories. That's an inference that's pretty logical. But then that would be problematic because the data set's created by us logging our budget and what we spent, right? So when you create a budget and your record is, I spent this on that, I spent this on that, we're not logging cases where we didn't spend. I don't know if you're like me, I don't even have time to budget, much less what I didn't spend. I didn't buy a new house this month. Okay, I didn't buy a new Viper. Yeah, I don't have that kind of time. So logically, If we have null values or NAs, that's a problem because maybe we didn't get the right data file that we intended to hand over to the financial advisor. We would question that finding because amount is very important. That's the only way we're going to be able to determine our spending. So you would then have a decision. Do I ask for a different file? Maybe they gave me the wrong one. Do I ask them why there's blanks and things? I'd have to make a decision. If they say, "Oh, I accidentally, didn't fill it in, but it doesn't matter because the stuff I spent is there." Okay, then I'm going to delete all the records that have NAs because I can safely do that without jeopardizing my ability to gain insights, right? But you don't want to do that unless you have those facts in front of you. All right. So again, missing values or NAs are very important and they need to be dealt with very methodically, because you could actually delete a whole bunch of data that, compromises your ability to analyze your data. All right, we're going to bring down one more code cell and we're going to do something that I think you'll remember, and that's descriptive statistics. We're going to check the descriptives, right? So check descriptive statistics. All right. And that is done very easily by doing df.describe. And we've done this before. And again, paren, it's a function. And that gives us our count, our mean, our standard deviation, our minimum, our max, and the interquartile range, the 25% percentile, the 50%, and the 75. So the interquartile range we're going to be working with a lot. I'm just going to go ahead and tell you that 25% is Q1, 50% is Q2, and 75% is Q3. And that's all I'm going to say about that. All right. Now, in looking at this, our minimum is 0, our maximum is 1750. All right. Now, that might seem mysterious. We're going to have to find out what's 0. Okay. Because 0 is a value. And it looks to me like someone put something in and maybe there's 0 spending on it. So that jogs my mind like, wait a minute, is that appropriate or not? We'll find out. I will give you a hint. It's okay. They were told to put zeros in, but they were told not to leave it blank or put NA. Okay. So, and the reason for that is every month, when I have categories of possible spending, every month I could possibly spend. In some cases, we spend on everything, right? So, or in some months we might not spend, but we want to make sure we put a data point in there so that we know we did not spend. We don't want to leave it blank and we don't want to make it NA. We want to be numeric. Why do we want to be numeric? Remember the histogram. If I've got NAs or nones in my data, I cannot create that bell curve. Remember that beautiful chart? It'll yell at you and say, sorry, you've got text in there. I'm a histogram. I can't do that. So that's why we put a 0, because a 0 is still a number. Okay. So that's why we have min. But the other thing to notice is we've got a heck of a range here. Do you remember how to calculate the range? Anybody remember how to calculate a range? Max minus min. Max minus min. So if I take my max value and I subtract 0, that's my range. That's my spread. That's huge. That tells me I've got outliers. I've got outliers. Highly likely. I will test that theory. But at this point, remember, I'm exploring my data. I sense that we've got an outlier situation. Here's another reason why I know we have an outlier situation. Look at the 75%. It's 150. Big gap between that and the max. That means that we have, and we're going to do a box plot, but we have outside our whiskers lots of data. So you can be proud to talk about your whiskers and your data. Outside my whiskers, I've got lots of data. So
The budget, is that what that tells you?
Pardon?
That they're going over budget, like,
Well, not necessarily over budget, but there's some amounts that are higher than usual.
Okay.
Remember, we talked about there's going to be cases where we spend more in a given month. It's highly likely that there's some seasonality associated with that.
Oh, okay.
Summer, remember we said like summer or holiday. So that's, but again, that's what we know about. Think of it this way, and this is a very good point, and I'm glad you asked that question. When we go into this, we all have budgets. We don't want to bring our own biases to the table, and we don't want to say, well, budgets are always done like this, or it's always the case that a budget is done this way, or spending is this way, because we're bringing in our own experience. You always want your data to tell you what's going on. You don't want to tell the data what's going on, and you don't want to assume, right? So when you see this, you say to yourself, I don't know what's really going on, but based on my training and the numbers I see here, it looks like we have outliers. I don't know what the outliers mean. They may be valid data points based on spending behavior, but I wouldn't want to take my own spending behavior and say, oh, my max is usually 50,000, so this is small, something's wrong, right? I don't want to do that. Now, mind you, my max is not 50,000 in a month, I can tell you, okay? But I'm just saying, you don't want to interject your own personal experience of your budget into the data science process, because while your spending may be different, you don't want to make an assumption that all spending should match your pattern or your understanding, because we're all different and we all do different spending, right? So you always want to just remember that. Don't take a biased approach to your data, because it will yell at you. Okay. Now, what this has done and it's given us the central tendency, which is the 50%, right? So 100 is at the center, the dispersion and the shape. Now, what this has also done is if there are NaN values, right, or none or Na, those will not be included in this. Okay, you can do descriptives on data, a data frame that has NAs in it, and it will allow it. It ignores them. It says non-numeric, can't do it, but I'm going to give you what I have. Okay, so that's just something to remember. You can do descriptives. All right, let's do one more. We're going to click on the next code cell.
I have a question, Professor.
Yes.
So, as I was looking at the little right hand side, is showing that it's suggesting chat. What does that mean?
It's suggesting chat.
Yeah, yes. Like, what does that mean? Like, if we want to do like a chat for this descriptive that just came out.
Oh, so these little blue icons? Yes. So and yes, so in Google Colab, you can actually do charts and things. I'm going to show you how to do it programmatically. Those are some of the automated tools. So we're going to not use them right now, but exactly. It's kind of it's a new version of Python in Google Colab that gives you some additional tools, which make it easier. I will tell you though that the charts are, they're okay, but we're actually going to build our own. So yes, that's what those blue charts are. Absolutely. Yep.
Thank
Excellent.
you.
You're welcome. All right. The last thing we're going to do is get a random sample of our data. Okay. Now, we're going to do this. We're going to comment first so you know what this does. Show a random sample of my data. Now, why a random sample? Because the data could be all over the place. We want to see a hunt and peck kind of approach to different rows in our data set. We don't want to see the first 5 or the last 5. We want to see just a random selection so that we can get an idea as to what's in the data. Okay, so I'm going to type df, that's my data frame, sample, and I'm going to tell it I want 10 rows of sample. Okay, so it's a random sample of items. Okay, so my sample is going to be different than yours, just so you know. That's what random is all about. So when you do a random sample, you can see the index that it brought in. It's all over the place. Remember, our data set's only 300 and some odd rows, and we can see that it jumped all over. It got in the 90s, 48, 35. For me, it hunted and pecked throughout, and it gave us a random sample. Okay. Does everyone see that?
So why is your data different from ours? Aren't we using your own data you gave us?
Okay, we're using the same data, but the laws of random is that what I see, this is random. So to be truly random, right? Which we're not going to talk about true randomness because that's the topic for another day, another century. Too much math, all right? But mine is going to be different because your system's going to pull 10 random. The person next to you is going to, right. That's what a sample is. Now, sampling is what data scientists and also researchers do. They take a sample of the data and they will analyze it and make inferences about or try to generalize to the larger population. So let's say I'm the financial advisor and I have in my data set the budgets from 5 different families. And let's say I want to do maybe I'm doing some research on typical family spending, right? I would do a sample and then I would analyze it and then try to make inferences about what the typical population spends budget wise. So that's a research type of technology or technique, right? This is done very similarly where we're doing a random sample. We want to see random pieces of the data. Now, each time you run this, you can actually cycle through and randomly see the data to see if there's any unusual patterns. So when I click on this each time, I'm going to get another representation of random 10, and it's going to show me. And if you do this maybe a couple times and everything looks okay, you don't see anything unusual, you can make an assumption that the data is well formed, it looks reasonable, there's nothing unusual. Nothing jumps out at you is basically the point. It seems what I'm going to call consistent. Does that make sense to everyone?
Yeah.
Okay. All right. Okay. So now, do we need a break?
Yes.
Okay. Now we're going to take a break, and there's highly likely a chance that our family budget will disappear. We may have to re-import it. We'll know when we come back if it's not on our screen. So that's okay. I will walk you through. Okay. So why don't we take I'm going to stop sharing. Why don't we take a 5-minute break to get refreshed? And when we come back, I'm going to explain what to do to see if your data file is still there and how to pull it back in and rerun your code that you work so hard to run. Okay. All right. I'll see you in a few.
Okay.
And I'm going to share my screen again, and I'm going to show you how to determine if in fact you have been disconnected. All right. The easiest way, can everyone see my screen? Good.
Yeah.
All right. The easiest way to see if you got disconnected is to click the cell that you just ran before you left to take a break, right? So if you run that again and you get a result, you're good. You didn't lose your connection. Okay. All right. Now, if you get an error that it can't find your data file, that means, obviously that you have to follow the steps that we use to get the data file in. You would upload it first, and then you would have to come up and rerun all of your code because that means that the entire notebook got disconnected. Okay. But we got lucky. Did anyone have an issue with running the last file or the last code cell rather that we did? Yay. All right. It's the little things, right? It's the little things. All right. So now we're in the process of exploring our data, and we're going to explore and it's highly likely that we're going to have to continue this because I see it's almost 20 after. We may have to continue this next class, which is perfectly okay. Just so that you know, I would want you to practice with the data sets, the Penguin data sets that I provided for homework. And at the end, I'll walk you through that. But you would only do what we did so far. I wouldn't expect you to do something you haven't seen yet, right? So you would do as far as you can. All right, so what we're going to do is add another code cell underneath the one that we just did. And I'm going to show you some really cool techniques. Now we're going to start to get into for example, there's oftentimes where you want to change how the data is sorted. Maybe you want to sort it by month, right? Which is really where we're going with this. Notice that in the month column, our data is sorted in a very unusual way, right? It's all over the place. It's not by calendar month. So I'm going to show you how to change the sort. So we're going to put a comment in, change the sort order of the columns. And in this case, we're going to specify the column of interest. Okay. So I'm going to create a new data frame and I'm going to call it sort. Whoops. It helps if I spelled it right. Sort by month. And I'm using underscores because we want to be able to visually see it. Sort underscore by underscore month equals the data frame dot sort underscore values. And in the parentheses, we're going to put the column we want it to sort by. And in this case, we're going to choose month. Now, when we run this, we're not going to see anything. All it did was take the command sort values for the given column and assign it to a variable called sort by month. In order to see what we did on the next line, and again, I'm just going to do it right underneath the one that we're working on, we want to call what we just created, which is sort by month. It's actually a new data frame. All right, a new data frame. Now you'll notice that it's doing the entire data frame, and in the middle you'll see some dots, right? And that means it's only able to show you so much of the data frame. All right, because of screen size, right? So what it did is it kind of truncated it. It showed you the beginning and the end of the data, which is fine. We can see what we expect though, and that it is sorted, you know, in month order. There's no question that it's sorted in month order. Okay. All right. Does everyone see that? Now, to test our theory that it is in fact correct, I'm going to add a new code cell, and I'm going to call sort by month again. But in parentheses, I'm going to put 10. Now, you might be wondering, why can't I call this particular data frame this way? Well, it's an object that can't be called. So if you try to, show me the first 10 or the last, right? That's not going to work because we know that there's a different command that we use. But I've seen so many students do this where you actually will try to show some of your data by, calling the data frame object. So who remembers what the command is for showing the first 5 rows or the first 10 rows? Anyone remember from our prior class? Now, this was many moons ago. It's the head command. I won't trick you. It's the head command. All right. So you can't call a data frame, but you can call the object, the head, which is the top, and the first 10 records. Okay. So remember, data frames are data frames, but they have limitations. Okay. Now I'm going to copy this command because I'm getting lazy, right? I'm going to copy it, copy the cell, and I'm going to add a new code cell and paste in my command. And when I do that, it adds a new code cell. I can easily delete it. This blank one here, I can delete him. But if I want to see the tail, I just changed head to tail, and that gives me the last 10 records. Okay. So in essence, what we were seeing above is the same thing. It just didn't, it kept the middleman out, right? So here we're seeing 10 and 10, and it basically kept, and it appears that our data doesn't go past September. That's what it appears, right? What do you think? Is that a good inference based on the tail here? Does it look like we're at the end of our data set?
Past data, yeah, so it doesn't go past September 30th. Here.
September 30th. Okay. So based on that, that's what we're seeing here. All right. We will test that theory. One of the problems that we have here is that, well, I see things that are kind of interesting. I would say to myself, well, what did my client tell me the data set should be? That would, it doesn't appear to be a full year. Did I perhaps ask them to give me whatever they had? That's just something we want to be thinking about. Do we have the whole data set? Okay. Now, next thing we're going to do is we are actually going to, and keep in mind, another thing to remember is you sorted by month, and that's the data frame you're using. So don't get confused. If we wanted to do the same,
By
if we
date?
wanted, we could, if we wanted to do the same with DF, we could do the same with just the DF, which is the original data frame, right? So we could do df.head, right? And say, show me the top 10, right? So we actually have two different data frames. Does everybody get that? Because I wanted to make sure I don't, confuse things here. Okay, so we created another data frame. We actually copied the original data frame into a new data frame and sorted that one. So one sorted, one isn't. Pretty neat, right?
Mhm.
All right. Let's
And
look
I need
at,
both.
pardon?
Sometimes you might need both because you want to see the beginning of it
Absolutely. And one of the
and
things we're going to be
then
doing
maybe
is a
I don't
lot
know,
with different
right?
data frames. You got it. So we're going to bring down a new code cell. Now, I talked before about outliers. I'm now going to show you the outliers in, in real time. So the goal of this is to check for outliers. Because based on our summary statistics, it appeared that we had something going on. But we are only going to check the amount column. All right, we're only going to look at one column. All right, because remember, this is budget. We're looking at outliers in the budget aspect, which is amount, right? Dollars. So we want it to print, and the print command, very important, always has a parentheses after it. And in the parentheses, you tell it what to print. So we want to print from our data frame using the amount column. Okay, so amount, and get value counts. So how many value counts, and sort it by the values found. Okay. Now, again, think of the goal. Check for outliers. Well, once we have outliers, we want to know how many. How many do we have in each, right? And what each is, it's amount. For each spending amount, how many of them are there? Now, what that's going to do is tell us, do we have a lot of individuals, like ones for the higher ones and a lot for the lower ones? This will tell us a lot. So I'm going to run this, and voila, holy moly. We got outliers. We got outliers. Was everyone able to run that command?
No.
Okay, well, wait till you can. Just double check. Remember, you've got square brackets around the column name.
All right.
Because it's inside the CS.
Oh, I see. Okay. Oh, okay. Got it.
All right. All right. So now we see that we have one case of spending 1,750, right? And we have a lot of common cases, like 100. We have 49 cases where we spent 100, right? We see a lot of 11s and 12s. All right. We see 13s, 18s, 21. So we see high frequency for some, right? And I would say everything from here down is probably in the bell curve, right? They're high frequencies, they cluster around the mean, the average, and we've got a lot that fall outside of that. And that's these guys here. These guys are going to be your outliers. All right.
Could we also use the type of system to like analyze departmental budgets, like, you know how some companies tell you, we are spending too much money, we don't know where it is going.
Absolutely. Absolutely. Yes. Yes. Because each budget, when a department has a budget, they have budget lines, and the budget lines usually get assigned a code. The code would be your categorical way of tracking the category, right? So you would be able to categorically see where spending is happening and the related dollar amounts. Whereas we're using a different category, we're using like housing, what have you. Usually in a department, they have a budget code. All right. All right. So that would become your category because they assign a budget code. All right. And so, and of course, there would be a month when the transaction happened, and so on and so forth. And of course, a dollar amount. So, absolutely. So, does everyone understand how we were able to identify our outliers? Now, it's good to see them like this, but it would be even better to see it in a chart. And I'm going to show you what I mean by chart. We're going to bring down another code cell, and we want to visualize outliers in the amount column. Remember, a graph is going to tell us a lot more. So the question becomes, what type of graph? A box plot is the classic way of showing outliers. It actually has whiskers, and we like them because it tells us where the data is falling. All right. So again, our data frame, we want to use the amount column. Okay.
Everyone, the library will be closing in 30 minutes. Please come to the
Okay.
30
All right. I heard that. All right. Amount dot plot. And the kind, we're creating a plot. The kind is going to be kind equals box, meaning box plot. All right. So DF amount, again, amount is the column of interest. We're plotting the data in the amount column. And the kind of plotting we're doing is a box plot. And I'm going to explain what this means once everybody has it. Was everybody able to generate their box plot?
Yes.
Woohoo! Now, remember before I talked about Q1, Q2, and Q3, right? Q1 starts at the bottom blue line down here. Okay? Did everyone see that? That is your top whisker. So it's towards the bottom of the chart. That's your top whisker. The box in the center is your 50th percentile, and the green line is the mean. Okay? And then the top whisker, which is the horizontal line, is Q3. All right, the 75th percentile is everything from the whisker to the box. Okay, does everyone understand that?
Yeah.
The dots outside of the top whisker are the outliers. Okay. Does that make sense? So if I were to ask you, do you know that there's outliers in your data set? What would you tell me?
Let me run the data to very clear.
What's that?
Oh, wouldn't I, you just telling me like that or without even?
No, that was a question. If I were
Oh,
to ask you, are there outliers in the data set? What would you say?
yes, because
Yes.
they're outside of the data set, outside.
Now, how do you know there's outliers?
They're outside the whisker.
They're outside the whisker. Perfect.
Yeah, look at that. She's good.
Outside the whisker. Now,
Wow.
keep in mind, you could have outliers outside the top whisker too, which is at the bottom of the chart, right? So anything outside either whisker, remember a cat has whiskers on both sides, right? Anything on the outside of the whiskers are outliers, either on the low side or the high side. Okay. Now, does that mean it's bad? Not necessarily. The first thing you want to ask is, are these data points valid? Are they reasonable? And if yes, if they're not accidents, right? They're not, typos and such, then the next thing you say is, what are the implications for including them in my data analysis? So I'm going to just throw something at you really quick. If I were to be doing prediction to predict future spending based on current spending, what would happen is I may make a mistake because I included the outliers and they're not typical. Let's say this particular year was unusual. Look at COVID, right? COVID changed everything we know about our budget, our lives, the whole thing. So you ask yourself, they may be valid, but given the seasonality of it, I would not be able to use these data points to make predictions for future, because seasonality is not always the same, especially when it comes to something like COVID, God forbid. Can you imagine having constant COVID? We wouldn't want that. But that was a season, all right, right? So if you decide to not include your outliers, now that we know we have them, and of course, I'm going to show you how to make that decision, but not tonight. If you decide not to include them, you would actually delete them from your data set, meaning you would have no more data outside the whiskers. So after you run that process, which again, we're not going to do tonight, you would rerun your box plot. And if you no longer have data points outside the whiskers, you got rid of your outliers. You see? So you need a visual. You really need a visual, because this tells the story. Whereas this up here, you say, well, it looks like they're outliers. The summary statistics showed what I believe to be outliers, but let me test it visually. And when you see it, it's unequivocal. The chart tells everything. And that's why data visualization is so important in this regard, because it tells that story. Okay. All right, so I think we're going to end here for tonight, because this will give you enough for your homework. Now, here's the thing. We want to make sure that all of our changes are saved. So it may say at the top, all changes saved. But if you're not sure, you're not, you're pessimistic, which is okay. We're talking Google here. Click File, Save, and that will make sure that this notebook is saved again in your Google account, right? That's the first step. All right. Now, I'm going to stop sharing my screen. You can log out of Google. That's okay. You can log out of Google because you saved it. It will be there when you go home and you log in again. I'm going to share the homework file so that you know what you're doing for homework. And it's a PDF. So let me just share that screen with you. Now, when you're doing your homework, let me go ahead and share here. Come on, Zoom, work with me now. Ay, ay, ay. You're only going to take it as far as your box plot, right? Because we didn't do anything else, but we will be continuing next week. So for your homework on OpenHub, there is a penguins.zip file. So you want to download and extract the data sets. There are 2 data sets found in the Penguins file. You can do one or the other or both. I leave it up to you.
Okay.
Penguins are fascinating creatures, and this particular data set has been used by researchers in the world. So you will actually learn a little bit about penguins and some of their characteristics. How cool is that? When you look at your data set, you want to remember all the things we talked about. You want to create a new notebook, organize it the very same way that we did for class. You're going to select one of the data sets or more if you decide. I would start with one, and you want to perform exploratory data analysis in a Google Colab notebook. Obviously, you're going to save it and share it when you're done. Use the outline of the project that we did tonight. Remember, that's going to be very important for you. And then, of course, share the link to make sure everyone with the link can view it. Now, one of the key things, I'm going to stop sharing our screen here. One of the key things is, when you're looking at your data, remember, no 2 data sets are the same, but our process, our methodology is the same, right? In other words, we could expect with the Penguins file to have more numeric data. I will tell you, wink, wink, hint, hint, there's more numeric data than we have in the file we used. Is that a good or bad thing? That's okay. It's a good thing. But we want to know that we have numeric versus categorical values. We want to be able to be comfortable in what we're seeing when we see a new data set. In research, or in data science rather, this is called Viewing a novel data set. In other words, a data set I've never seen before, I look at it. Can I recognize the patterns based on my training? Can I go through that same process and efficiently gain an understanding of the data? So those are the muscles we're building right now. So any data set you see, you shouldn't be afraid of it. You should say, this is new territory, kind of like a new project, new exploration, new information, and be excited about it. Don't be intimidated by it. You know, it might be a huge data set. It might be lots of null values. It might be this, it might be that, but you are building the skills to be able to address and have that data talk to you, right? Tell the story. That's really what this is about. So it's no different than maybe you performing a new exercise that maybe it makes your muscles hurt. It's a new exercise. You didn't use those muscles yet. So
Mhm.
that's how you want to look at it. Don't be afraid of it. Okay. Any questions about what we've done tonight?
Mm.
And if you have questions, just ask them the way you understand them. Don't be afraid because, as we're building, I'm sure questions will happen.
Mm.
Everyone's like, I'm going to go home and analyze my budget. So, yeah. So next week we will continue with that. We should hopefully finish next week on that family budget. And the reason I'm doing this instead of jumping into Airbnb is the poll that I put out on Slack said that some of you wanted a refresher. You were still a little unsure. And so I figured starting with a smaller data set would be easier for you rather than going to a data set that's larger. And that's perfectly okay. It's the learning that's important. The skills that you're learning and applying to this smaller data set will be identical to that which you do with the Airbnb. So it's okay that we're doing this. I think, it'd be better for you. And I want you to be comfortable, and that's really the goal. So each time we do these classes, we will assess based on last course, do you feel ready to go or do we need to maybe warm up, this warm up exercise? Okay.
I have a
Any,
question.
yeah.
So how different it is, like if I were to be hired as a manager and I'm doing data analytics for that day or that month, is this something that I will actually do, or does that company will have like specific way of going about analyzing that data because they had to make quick decisions?
Well,
Versus
so data, that's a great question, actually. That's a really good question. So typically, the analysis that you conduct is based on the goals for the analysis. However, when you're working with a new data set, you still have to do exploratory data analysis. So that process will be the same. The problem is it's highly likely that the company may not give you enough time to do that. They expect you to jump right into the analysis.
Right.
That's not a good thing because the data, let's say the data was exported from the server, and let's say there was a problem or there's unusual data points. You may attempt to do the analysis, they might rush you only to find out that you can't because of outliers, because of null values, because of none, mistakes in the data, right? So that exploratory data analysis you need to do. But as you get savvy at it, you will do it quicker. And so you'll already have a notebook, a template ready to go, and that's the purpose of it, is to do exploration. So you just tweak the notebook, explore, make sure all's good, and then you go to the analysis. And that's where you're building notebooks for your workflow. You don't reinvent the wheel. You have all the code ready to go. You just bring a new data set and then you change for the columns you need and so on. You make it so that you can quickly make sure that it's even analyzable. There's been cases where you try to, work with a data set, and it's rare where you can just jump into like machine learning or into, building charts and such because the data has got problems that have to be addressed. And if nothing else, outliers are a problem. It won't cause errors, but it will skew your understanding for analysis purposes. And remember, the whole goal is to gain insights to make decisions. So you are correct in that the process will be the same, but you may have to explain it to the folks around you when you're taking time to do the work, because you're being trained in a science, you're being trained in data analytics, and that's a
Right.
specialized skill. It's no different than an accountant. right? An accountant has a certain thing to make sure that there's quality and integrity. And if they don't have that, then when they go to report, to corporate reporting for financials, annual reporting, or reporting to the IRS, they make mistakes, and then what happens, right? So they have to follow GAAP principles, generally accepted accounting principles, and that's a specific process. We're following the CRISP DM framework. That's our process, and it has a certain regimen that you go through. So rationale for it. Same thing with a surgeon, right? They have a certain, it has to do with cleanliness and how the tools are disinfected and, all those things. If they rush that process, they run the risk of harming someone. So,
I'm sorry, but sorry to cut you off, but
Mhm.
if it has there ever been an instance, because I keep thinking about applying for this particular position where they said this couple of months or the past 5 months, we keep falling short in our goal, and this is now our budget, this is our number, this is what, and they give you all this data. Is there any way, do I have to go through this process when this person is kind of like on my face, waiting for a result? How many employees do we need? What do you think is wrong? And do
right.
you
So,
still kind of look at them and like
well,
meditate, breathe,
yeah,
and then explain to the person that
right.
you have
So
to like sit with it, or
here's what I would say. Um, they're going to want an answer right away. And
right?
the best way to explain it to them is, in order for me to give you the most accurate answer, the most responsible answer that's going to allow us to make effective decisions, I need to take the time to analyze the data. And there's a certain workflow that I have to use. And they have to understand that. If they don't give you the time you need, you're not going to be able to give them accurate answers, reliable answers, valid answers, and that's going to impact their ability to make decisions,
Bottom line, yeah,
right?
yeah.
And so if something's critical to their future success, it's an investment of time now to resolve it so that you don't keep making the same mistakes. Let's say there's a misallocation of funds, and do they want to keep recreating that problem? Right? That's not going to be sustainable for them to spend that kind of money. So you have to explain it to them in business terms. You have to make a business case for the time that you spend in the chair to analyze the data. And if they rush you or try to push you, say, I need to be methodical about this, because if I rush it, we may misinform ourselves. We will not be able to solve this problem. And
Mhm,
and you could always say to them, I appreciate your patience. Right,
mhm.
right. And they may not understand, and that's okay. They probably won't understand, and that's
Right,
okay. It's, and I know they will put pressure.
right.
That's how it works. That's how it works. But that's where you know how to effectively respond. Instead of saying, I need X amount of time, blah, blah, blah. You say, in order for me to do this properly and to give you accurate answers, accuracy, and ask them, are you interested in accurate answers? You have questions. Do you want accurate answers? They're going to say, of course I do. Okay, I need a day. I need 2 days. I need some time. Okay.
Mhm.
Um, and be ready to be put in the hot seat. That's why you're getting the training,
That's right, that's right. Thank
right?
you.
And your confidence in your skills will help deal with the incoming that comes to your desk, right? So your confidence in your skills allows you to respond in an emotionally intelligent way.
Right, right.
Okay.
I love that, emotionally intelligent way. I love it. Thank
See?
you.
Excellent, excellent. Let's see. Do we have any questions on Zoom? I don't see any. I see a lot of I have
Fingers
to go,
crossed.
which is fine. All right, everyone. I look forward to seeing you next week, and I look forward to seeing the posts on Slack. Make sure you go to office hours and have a wonderful weekend. Okay, everyone?
Thank you.
You're welcome.
Professor, have a good day.
You too. Take care, everyone.
Bye-bye.
Good night, all.
Thank you, Dr. Silvia. Thank you.
You're welcome. You're welcome.
You're welcome. Sure.